understanding of it has evolved dramatically. Thanks to new observations, we now have not only unprecedented views of its surface, but a whole new tour of the Moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We now head to the far side of the Moon, which cannot be seen from Earth.
So this is like the world's most important freezer.
It is, really. The most important room in the world, someone has said.
These are pretty big claims for a place located just 1,300 kilometers or 800 miles from the North Pole. But then, this is no ordinary place. It's the Svalbard Global Seed Vault.
And that's what a night vision camera can pick up. That sort of light is called infrared light. And this is an ice cube.
Nearly a mile across and over 500 feet deep. For the longest time, it was assumed to be a volcanic crater. Named simply Meteor Crater, it's the first geologic scar ever confirmed to have been created by a collision from outer space. Hundreds of other craters have been identified since, but Arizona's remains one of the most spectacular.
Veins go into the heart and arteries go away from the heart. So the freshly oxygenated blood comes into the left atrium, which is also this part here.
The video that you'll be looking at is large magma bubbles. They're about 3 feet across, and the bubbles are molten rock that are expanded under the pressure, the gas pressure of magmatic gas. That on planet Earth, this is a process happening all the time, and yet we have never seen it happening in quite this way. The ocean floors are formed almost exclusively by volcanic activity. And strangely enough, we really have never seen molten lava flowing on the seafloor from a submarine volcano.
Now during prophase 2, there's no more crossing over, but what's going to happen is those two chromosomes are going to line up. Again, they're going to meet right in the middle, and the spindle is going to attach to each of those centromeres. Now,
In case number 1, when the block is moving in a direction parallel to its long cylindrical axis, The cross-sectional area that is perpendicular to the direction of its velocity is a circle whose area is pi times the radius squared, or pi times 1.5 centimeters squared, which is about 7.1 centimeters squared. And in case number 2, when the block is moving in a direction perpendicular to its long cylindrical axis, the cross-sectional area, which is perpendicular to the direction of motion, is a rectangle whose area is the diameter of the circle times the length of the cylinder, or 3.0 centimeters times 13.9 centimeters, which is about 42 centimeters squared. Which means, because the cross-sectional area is smaller in case number 1, like the race car, it is more aerodynamic, and there would be a much smaller drag force on the cylinder if it is moving like it is in case number 1.
Okay, today we're doing the cow eye dissection, and let's begin by looking at some of the external anatomy of the cow eye.
Let's get to work. Here's a mirror, plain mirror, and here's a beam of light coming in. And you see that as the beam of light comes in, it's going to leave at the same angle as it entered. This mirror is concave over here. So as I come in parallel to the axis of the mirror, I leave, always sort of aiming at a certain point. Do you see this point where it's always kind of hitting? I might call that the focal point of the mirror. I got a diverging mirror now. Check it out. See, it causes the ray to go up, and down here the ray goes down. Yeah. Ooh, this is getting really hot. Wow. Yeah. Good.